This is aiming for a 9 Spring 2020 practice. It's paper 1, so it's non-calculator. And it's obviously higher tier. So I think you have, so you have an hour and a half to do this full paper. Prove algebraically that the sum of this and this is always a square number. So when you get this question, if you get a question like this, the first thing you want to do is expand. So if you can expand in a question, just do that. Here you'll get half n squared plus half, plus a half n. And then here, just expand the inside to get n squared plus 3n plus 2. And then a half of all of that. And then just distribute the half. So it'll be half n squared plus 3 over 2n plus 1. And then just sum these together. So a half n squared plus half n squared is n squared. And then it's 3 over 2n plus 1 over 2n is just 2n plus 1. Like that. And then this, you can factorize this to get n plus 1 multiplied by n plus 1, which is just n plus 1 squared. And therefore it's always a square number, because anything squared is a square number. ABC is a parallelogram. A is A and OC is C. X is the midpoint of the line AC. OCD is a straight line, so that OCCD is k to 1. So OCCD. And given that x to d is 3c minus a half a, find the value of k. So you've got this here. Okay. And okay, so you have OCD, which is a full straight line. So one way we can find OCCD is just by figuring out what this full line is, what OD is, and then taking away OC, because we know OC. And then that'll give us CD. So then we've got OC, CD. Now we can just put it as a ratio and then reduce it down to this. So let's do that. That's basically what I've just explained. Okay, so how to get to OD. So one way we can get to OD is going O to A to X, and then X to D. We know what O to A is, because that's A, the question tells us it. And now A to X, it's a little bit trickier, but because X is the midpoint of the line AC, as the question tells us, if we go minus A plus C, and then do a half of that, that gets us from A to X. Because minus A plus C is A to C, and so half of that is minus a half A plus a half C, which just gets us to X. So O to A is A, then X is half AC, AC is this, so plug that into there. So A to X has to be minus A plus C, but a half of it, so A to X is minus a half A plus half C, like I've said. This is just showing it the longer way. Okay, so we've got A to X, we've got O to A, and we've got X to D, because the question tells us X to D. So we've got everything we need here, so just plug this into there, plug this into there, and plug this into there. To get this, simplify it, so OD equals 7 over 2c. And now we know that OD is 7 over 2c. And to get CD, we do CD equals OD minus OC. So this full line minus this small line gives us this. So 7 over 2c minus c is just 5 over 2c. So the ratio here is c to 5 over 2c. And we can cancel the c's to get 1 to 5 over 2. But we want this here to be a 1. We want this number to be a 1. So multiply by 2 and then divide by 5. So k must equal 2 over 5. ABCD is a rectangle. The lines A, E, and B are points on the straight line L, with this equation. So just put this into a usable form to get this. You can just rearrange, so minus 12, minus x, and then divide everything by 2. A and D are points on the straight line M. I don't think I actually used D here, but it doesn't really matter. You can use it, I think. And AE equals EB. So AE equals EB. So we know that line M is perpendicular because this is perpendicular. This is a 90-degree angle. And whenever two lines are perpendicular, their gradient is going to be a negative reciprocal. So here, negative reciprocal of minus a half is just 2. So line M has equation y equals 2x plus c. Now we'll just leave that in the back of our heads for a bit. So let's just figure out what points E and B are, so what the coordinates are. So here, just using a bit of intuition, but just imagine that there's two ways you can do this. So this C here, so y equals mx plus c, this C is the y-intercept. So this point definitely has coordinates 0, 6. If you can't think of that straight away, then just plug in x equals 0, because you know on the y-axis x is always equal to 0. So just plug that into there to get y equals 6. That coordinate is 0, 6. And you do the same thing for this one, but on the x-axis y is always equal to 0. So if we put 0 equals minus a half x plus 6, and then rearrange to get x equals 12. So this point has coordinates 12, 0. Okay, and we know that point, and we know that lines AE to EB are equal. So to get from B to E is the same as getting from E to A. And how do we get from B to E? Well, you go 12 to the left, and you go 6 up. So 12 to the left, 6 up. And this is the exact same as getting from E to A. So 12 to the left, 6 up. Okay, so 12, so we had to minus 12 to go in the left direction, so we get 0, and then we had to add 6 to go upwards. So here, just minus 12 again to go to the left direction, so you have minus 12, then 6 and 6 is 12. So this point's coordinate is going to be minus 12, 12. And we know that line M goes through this point A, because the question tells us. So just plug this into line M to get what the y-intercept is. So you get c equals 36. And then put that into the full equation, so y equals 2x plus 36. Solve algebraically the simultaneous equation. So we just want to rearrange for one of the variables and then plug that in to work out what the answer is. So here it's easier to go with y equals, because if we went with x equals, then we'd have to deal with fractions, and that's just not very nice. So y equals 3x plus 13 here. Just add 3x to both sides. Plug this into here. So you have x squared plus 3x plus 13 squared equals 25. So you have 9x squared plus 78x plus 169 here. And then collect like terms. So x squared and 9x squared is 10x squared plus 78x. And then minus 25 from both sides. So plus 144 equals 0. Here we've got, we can divide everything here by 2. Let's get this. I'm using the AC method. If you don't know what it is, then just do a quick search for it, and because I'm not going over it right now. But if you know it, use it. If you don't, then do whatever you prefer. This is non-calculated, by the way. So you're definitely going to be factorizing. Okay, so to get this, and then that will give you this, so x plus 15, x plus 24, and then just obviously divide by the coefficient of x squared to get x plus 3, 5x plus 24. So x must equal minus 3, and x must also equal minus 24 over 5. Plug this into any of these equations, it doesn't matter. I've picked this one here because it's the easiest. So if I start with x equals minus 3, so minus 3 times by 3 is minus 9 plus 13, which is 4. Y equals 4. Same thing for this one. I don't know what that is off the top of my head. Y equals minus 7 over 5. So these two pairs and these two, this pair and this pair. Given that this, find the possible values of x. So whenever you get a ratio like 1 to 2, it's the same as saying 1 over 2. So you can, whenever you see a colon, you can read it as over instead of 2. So x squared over 3x plus 5 equals 1 over 2. So just write that down. Cross multiply across, so 2x squared, 3x plus 5. Rearrange to get them all on one side, and factorize. I've used the AC method again, so this is going to be x minus 5, x plus 2. Like this, and then use the AC method to divide by the coefficient of x squared. get this. So x equals -1 and x equals 5/2. Usually, I've written that down here, we'd discard a value if it gives us a negative ratio. Here that is not the case, so we can keep both values. So if ever you're solving a question like this, and one of the values gives you a ratio that's negative, then you can discard that value because you don't want it. It doesn't work. But here, -1, even if we plug it into here, we'll still get positive because 3 times by -1 is -3, plus 5 is +2, and then -1 squared is obviously just 1. And then this positive will still be positive. So it still keeps it positive, so it's fine. A and B are two similar cylindrical containers. I've just put a note up here, so if you read through this question, we've not been given any values. So we can just choose what we want them to be, as long as they conform to the ratio. So what that means is, we have the ratio of the surface area of A to B, and we're told that that is 4:9. Okay, so we don't know what the actual volume of this is. We don't know what the volume of this is. This could be 8 and this could be 18. It doesn't matter, as long as it's in this ratio of 4:9. So this could be 4 and this could be 9. I'll just pick that because that's the easiest thing to work with. Tyler fills container A with water. Okay, so we're going to be using volume because this is being filled on the inside. Pours all the water into container B from container A and repeats it until container B is full. Work out the number of times that Tyler fills container A with water. Okay, so we want to get the volume of these two shapes, but we don't know what that is. We know that the area scale factor, the area scale factor is going to be 4:9. So the volume scale factor is going to be the cube of the length scale factor. So let's just write the area scale factor here. Now let's go to the length scale factor to square root, so 2 to 3. And then cube that to get the volume scale factor, so 8 to 27. So now this has a volume of 8, this has a volume of 27 units cubed or whatever it is. And we want to know how much this goes into this. So this per this is the same as saying 27 divided by 8 to get 3.375. You don't even need to work out this these decimals, as long as you know it's 3 point something. And then that tells you, well, you're not going to fill it up 0.375 times. You just fill it up an extra time, and then you just get rid of the extra water that you have. So you fill it up 4 times. White shapes and black shapes are used in a game. Some shapes are circles and the rest are squares. White shapes to black shapes is 3 to 7, and the white circles to white squares is 4 to 5. Black circles to black squares is 2 to 5. If you just look through this question, they've used of so many times. So 1, 2, 3, 4, 5, 6. We've used it tons of times. Whenever you see of in a question, it means multiply. So just remember that. Somewhere in this question, we're going to be using multiplying. Okay. Anyways, let's just carry on. So, like I said, like we did in the last question, we've not been given any values, so we can just say the number of white shapes is equals to 3, and the number of black shapes is equal to 7. So, total number of black shapes is going to be 10. Okay, so there's 3 and then 7, so there's 10. Same thing here, 4 and 5, so that's 9. 2 and 5 is 7. Okay, so the number of white shapes is going to be 3, because we said there were 3, out of the total, which is 10. And the number of black shapes is going to be 7 out of the total, which is 10. So it's 3 out of 10, 7 out of 10. We'll do the exact same thing for the rest of them. So white circles is 4 out of 9. White squares is 5 out of 9. Get that. Black circles is going to be 2 out of 7. Black squares are going to be 5 out of 7. Okay. The way that I thought about this was, of the black shapes, how many of them are circles? Because we're looking for anything that's a circle. So just looking at the black shapes right now, 2/7 of, so 2/7 multiply by the black shapes, 7 out of 10, gives us how many black circles there actually are of the black shapes. So 2/7 are circles of the total black shapes. We've got the total black shapes as being 7 out of 10. So it's 2/7 multiplied by 7 out of 10, because of means multiply, and that's 14 over 70. We're going to be doing the same thing with the white shapes. So of the white shapes, 4/9 4/9 the circles of the total white shapes. Multiply the total white shapes. Total white shapes is 3 out of 10, so it's 4/9 multiply 3/10 to get that. And then, so we've got 14 out of 70 black circles, and then we've got 12 out of 90 white circles. So you just add them together to get the total number of circles, which is just 1/3. 3 solid shapes, A, B, C, are similar. Okay, so that tells us that the relationship between them is that there's going to be some sort of scale factor to get from one to the other. We can just represent that as a ratio because it's much easier to do it that way. And plus the question is looking for the ratio of the height of A to the height of C. We've been given the volume from B to C and the surface area of A to B. So the surface area, so the area scale factor is 4 to 25 of A to B. And we want the length because we want the height. So you just square root both sides to get 2 to 5. Now let's look at the next piece of information. So we've been given the ratio of the volume of B to C. So the volume scale factor of BC is 27 to 64. Now to get to the length scale factor from the volume, we have to cube root. So we do 3 to 4. So here we've got B is 5. Here we've got B is 4. Sorry, B is 3. So just write it down like this. This is how I usually do it. And you want the B's to match up. So we can put this all as one ratio. So we can multiply this one by 5 and multiply this one by 3. So you have 6 to 15 to 20. We want the ratio of A to C. So A to C is 6 to 20, but it simplifies to 3 to 10. And that's your answer. Describe fully the single transformation that maps triangle A onto triangle B. So we're going from A to B. So here we can obviously tell straight away this is an enlargement. Okay, so we've gone from a length here of 6 to a length here of 2. Okay, so from here to here we've multiplied by 1/3. If you can't think of that just off into your head, just think about this. So let x be the scale factor. 6 multiplied by this scale factor gives us 2. So 6x equals 2. So that means x must equal 1/3. Okay. So from here to here, the scale factor is going to be 1/3. Okay. But if we look at this shape, it's not facing the exact same way as this one. It's actually flipped. And the only transformation that gives us a rotation or a reflection with an enlargement is a negative enlargement. So we know that the scale factor isn't positive 1/3, it's going to be minus 1/3. So the only transformation that allows for a reflection and enlargement is negative enlargement. So it's going to be minus 1/3. Okay, and this doesn't give you all the marks because you need to write one more thing down, and that is the center of enlargement. So let's just, the way that you can do that is just by connecting the corresponding points. So just try and be careful with this because this shape has been reflected. So this one doesn't connect with this one. This one actually connects with this one. Okay, and this one stays with this one, and this one comes to this one because the shape has been moved. It's been reflected, sorry. So they all converge at the point 2, 2, so the center of enlargement is 2, 2. That tells us it's an enlargement with a scale factor of minus 1/3 and a center of enlargement at 2, 2. Here is a sketch of a curve. The equation of the curve is this, where a and b are integers. The points 0, -5, and 5, 0 lie on the curve. Find the coordinates of the turning point of the curve. Okay, so I've actually done this in 2 ways for you. There are probably more ways to do it, but this first way is what I saw in the mark scheme, and I think it's a bit easier to understand. And the other way is how I did it. So this first way, which I think would be easier to explain, is when x is 5, y equals 0. So just put that into here. Okay. Oh, but before I do that, let me just say that this here, the y-intercept, so the point where this curve intercepts the y-axis is minus 5. Whenever you get a quadratic, this last number, this c term, is your y-intercept. So it's minus 5. So y equals x squared plus ax minus 5. And when x is 5, y equals 0. Plug that in to get this. So a equals minus 4. Okay, and then just plug that back into this equation to get y equals x squared minus 4x minus 5. And then you can just complete the square in this to work out the turning point. So you have x minus 2 all squared minus 4 minus 5. So x minus 2 minus 9. X minus 2 squared minus 9. And then, so the turning point is going to be the opposite of this, which is 2. And then it's just going to be whatever this is, which is 9. Minus 9, sorry. This is the other way that I did it. So I've said that, imagine you have a double bracket. So first of all, we'll say that the y-intercept is minus 5, as we've been told. Okay, and imagine you have a double bracket. And this double bracket will give you this x squared curve, x squared plus ax minus 5. And we don't know what this point is, but we know what this one is. And the only way to get a positive 5 as an answer is by doing x minus 5 multiplied by something else. So it's x minus 5 multiplied by, let's call this coordinate minus t. So if that's minus t, then it's going to correspond to plus t on here. Because here x equals 5, which we know, because we've just been told x equals 5. And here we've called this minus t. So here x equals minus t here. And these two, if you expand this out, these two numbers here, they will give you the y-intercept. So we're saying that minus 5 times by t gives us the y-intercept, which is minus 5. So minus 5t equals minus 5. So that tells us that t must equal 1. Okay, so just plug that into there. So y equals x minus 5 multiplied by x plus 1. Just expand this. You get the exact same thing as we did on the other method. And then complete the square the exact same way to get the same turning point, 2 minus 9. ABCD is a quadrilateral. AB is equal to CD. Angle ABC is equal to angle BCD. So this angle are equal. This line is equal to this line. Prove that AC equals BD. So AC equals BD. So let's just draw these lines on. Okay. And one way that we can do this is with congruency. So if we can prove that this triangle here, triangle ABC, is congruent to this triangle here, BDC, then that tells us that this line here must equal this line, which is what we're trying to prove. Okay, so let's just write down what we know. So this line, AB, is equal to this line CD of this triangle and this triangle, because the question tells us that. So just say given in question. And we can say that BC is equal to BC, this of this triangle, and then of this triangle, because they share a common edge. We can say that this angle is equal to this angle, because it's given in the question. Then that tells us they're congruent by SAS. So SAS. And then that tells us that AC therefore equals BD. This is a typo, it should say BD, not BC. So AC equals BD. Sketch the graph of this, showing the coordinates of the turning point and the exact coordinates of any intercepts with the coordinate axis for 5 marks. So straight away, if you see a question like this, try to factorize it if you can. You actually cannot factorize this. I tried it and you can't. You can just put it into the quadratic formula if you want. You'll get the same answer. You can use another method, but what I did was I just completed the square. So complete the square on this, get this. Now you've got the turning point, so the turning point is 2 minus 13. And now you can solve for what x equals, because you just rearrange for x. So plus 13, then divide by 2, and then square root all of that, and then add 2. So x equals 2 plus or minus root 13 over 2. Like that. Now draw your coordinate axis on and roughly sketch this. Just try and make sure it's accurate, especially with the turning point being on the positive x side, so down here. And then just label that. So 2 plus root 13 over 2. The positive version of this is going to be larger than the negative version, because 2 minus a number is always going to be bigger than 2 minus a number, as long as that number is positive, which it is here. Okay, so the positive side is going to be 2 plus root 13 over 2. And the next one is going to be 2 minus root 13 over 2. Just make sure you write these as coordinates, so the y coordinate is going to be 0, and then that's it. Given that n can be any integer such that n is larger than 1, prove that n squared minus n is never an odd number. Okay, so we're just going to have a look at 2 cases for this. It's only 2 marks, so it shouldn't be too complicated. So for when n is even. So when n is even, we can just say that n is 2n, because any number multiplied by 2 is even. So just substitute n, 2n into here. So you have 2n squared minus 2n. So this gives us 4n squared minus 2n to give us this. And then we can take out a 2 from here to give us that. And that is never going to be odd, because anything multiplied by 2 is going to be even, which means it's never odd. Now for odd n's, the only way that n can be odd is if it's 2n plus 1. So any even number plus 1 is always going to be odd. So just put that into there. Get 4n squared plus 4n plus 1 minus 2n plus 1. So you get 4n squared plus 2n plus 2. No, just 4n squared plus 2n. Then you can take out a 2 again. And again, this is the exact same thing. So any number multiplied by 2 is just going to be even. So it's never going to be odd. So it's a multiple of 2, therefore never odd. And you prove that. The table shows some values of x and y that satisfy the equation y equals a cosine x plus b. Find the value of y when x equals 45. There are a few ways you can do this. You can just pick, say, like 30 and 150. I've gone with 30 because it's the easiest one to work with. You could go with other values, but I'll just pick this because it's the easiest. So just substitute x is 30 into here. You could also substitute y plus 1 plus root 3, but I'm not going to do that because I'm going to do it in a slightly different way. So cosine 30, you should know that is root 3 over 2. So just put that in. And we want to get from root 3 over 2 to 1 plus root 3. So root 3 over 2 multiplied by something gives us root 3, then add something to give us root 3 plus 1. So root 3 over 2 multiplied by something to give us root 3. So a has to be 2 here. Because if this is 2, then that gives us root 3. The only way we can get a plus 1 with that is if b is 1. Okay, so just substitute that into that equation there to get that. And then find the value of y when x equals 45. So you should know 45 is root 2 over 2. Just put that in. 2 multiplied by root 2 over 2. The 2's cancel, so it's root 2 plus 1. The ratio y plus x to y minus x is equivalent to k to 1. So remember, a colon, you can just read that as over. So y plus x over y minus x is equal to k over 1. So just k. Put that in. I've just said here that a over b is the same as a over b. Multiply out by the denominator. So you get ky minus kx. Bring the y's to one side, bring the x's to the other side, and factorize the y's out, so you get y bracket 1 minus k. Get that, and then divide by 1 minus k on both sides to get this. Then we need to factor out an x, because that's what they've done over here. Get that, and we also need to factor out a minus 1, because if we factor out a minus 1 from this top part, we'll get k plus 1, like we want. And if we factor out a minus 1 from the bottom part, we'll get k minus 1, which is what we want. A negative divided by a negative is just a positive, so you can just cancel them out to get that, which is what we want. OAB is a triangle. OPM and APN are straight lines. M is the midpoint of AB. OA is A and OB is B. O to P to M is 3 to 2. So O to P to M. So this is 3 lots of, this is 3. If this is 3, then this is 2. Okay, so this is going to be 3/5 of the full line. The full line is going to be, because if this is 3 and this is 2, the full line is going to be 5. So this is going to be 3/5 of the full line. Okay, let's just first of all put on the information that we know, so A and then B. We want to work out the ratio ON to MB. ON to MB. The way that we do that is by finding 2 paths to N from O. And by doing that, we can do this thing called equating coefficients. And then that helps us to figure out what the scalar multiples are, which allows us to work out what the ratio is. And I'll explain what that means in just a second. So, to get to O to N, there are a couple of ways we can do this. So we can say that O to N is some amount of this full line. But I'm not going to do that yet. Let's just have a look at what we do know before jumping headfirst into it. So we know that OP is going to be 3/5 of OM. Let's just write that down. And we know that OM is A plus B. So O to M is going to be, it's going to be A plus a half of AB. Okay? So O to M is A plus a half AB. And AB, that is minus A plus B. So plug that in to get that. Simplify to get this. So OP is 3/10A plus 3/10B. Okay? Now, let's just work out 2 ways that we can get from O to N. So one of them, which I said, was O to A, and then A to N. And another one is K lots of OB. And OB is B, so it's just K lots of B. And what that means is a fraction of B will give us ON. So this full line, if you say times it by a half, you'll get O to N. If you times it by a third, you'll get O to N. It's just anything. So any fraction of this full line will give you this, because there's going to be a part of a total, and a fraction is a part of a total. Okay, so let's just work with this one. So O to N is A plus A to N. So A plus A to N. Now, one way that we can get from A to N is by saying we can get from A to P, because A to P is minus A plus O to P, and we have that. So A to N is, okay, before I get to that, so we can get from A to P, okay? We know that we can do that, because I've just said it's minus A plus OP, and we've got minus A plus OP over here. Okay? And from A to N, it's going to be A to P multiplied by some number. So if we multiplied A to P by 2, that'd extend us further to get to N. Or if we multiplied it by 3, or 4, or 5, or whatever number it is, we don't know that yet. We'll just call it lambda. You can call it whatever you want. I've called this one K and I've called this one lambda. It doesn't matter. You can pick it. And we can get from A to P, because it's A to O and then O to P. So just put in A to O, which is minus A, and then O to P. That. And then we want to substitute this into that. So just, first of all, simplify this to get that, then plug this into that to get this. And we'll just leave that in the back of our heads for now. So A to N is minus 7/10A plus 3/10B, all multiplied by lambda. Okay? And that helps us because O to N, like we said, is OA plus AN. OA plus AN. Okay? And we already said what AN was. We worked out what AN was. It was this. So we'll just put these together. So plug this into there to get that. So, sorry, I've just simplified this first of all. Then plug this into there to get that. So now just look at this. So we've got to n, we've got to n. So these are taking us to the same place, so they must be equal to each other. Okay, so let's just put them equal to each other. And now this part comes to the equating coefficients part. And what this is, equating coefficients. So a coefficient is the number next to a variable. So the coefficient of a here is minus 7 over 10 lambda. It's a number next to whatever you've got. To equate coefficients, we need to look at the vectors. So we've got a and b. So let's equate coefficients by looking at the a's. So looking at the a's. Okay. Just look at the a's. So on the left-hand side, how many a's do we have? Well, we have 0. And on the right-hand side, how many a's do we have? Well, we have 1. We also have minus 7 over 10 lambda a's. So 0 equals 1 minus 7 over 10 lambda. So lambda equals 10 over 7 if you just rearrange that. Now we'll do the same thing looking at the b's. So b's over here, we have k b's. So we have k equals 3 over 10 lambda b's. So we have 3 over 10 lambda lots of b. So make that equal to each other. We worked out what lambda was. Here is 10 over 7. We'll just plug that into here to get 30 over 70, which simplifies to 3 over 7. And we said that this O to n is going to be k lots of O to b. And that makes sense because if we take 3/7 of this full line, that looks like it would be this, because it'll get us smaller, which is what we need, because O to n is definitely smaller than O to b. Okay, so it's definitely smaller, which is what we want. Okay, so this has to be right. So we'll just say that O to n is 3/7 of b. And b is O to b. So this full line, we take 3/7 of it, and that'll give us this. So that tells us that n to b must be 4/7 b, because it needs to add up to a b. So 3/7 b add something gives us 1b. So that has to be 4/7 b. So the ratio of O to n to b is 3 over 7b to 4 over 7b. We can cancel the b's on both sides to get that. Then we can multiply by 7 on both sides to simplify. So we get O to n to b is 3 to 4. Question 17. Oh, I actually forgot to change that one. So A, B, C, D are 4 points in a circle. AEC and DEB are straight lines. The triangle AED is an equilateral triangle. So AED is an equilateral triangle. Prove that triangle ABC, so this, and this, is congruent to triangle DCB. So this, and this. One way we can do that is using circle theorems. And okay, so we've got CDB is equal to CAB. And so whenever you have an arc here, you've got a chord. If you draw 2 lines coming out the ends of the chord, and then draw another 2 lines coming out the end of the chord, as long as they're touching somewhere else on the circle, these 2 angles will always be equal. Okay? So these 2 angles are always equal. So, okay, and that I'll show you why that helps us in just a second. Because of this triangle and this triangle, we've got one angle already the same. We can do the same thing here, because we've got another chord here. We've got an arc, so angles subtended from the same arc are equal. So here I can say that we're going from here to here, here to here. We've done the same thing here to here, here to here. So we've drawn 2 lines 2 times from the same arc, and that means that this angle is equal to this angle. So DCA is equal to DBA. Okay? And we know that they're equal. Let's just call them Y. Okay? And this triangle here, BCE, is going to be an equilateral triangle, okay? So this BEC is an equilateral triangle, and AED is also an equilateral triangle. So these two are equilateral. Okay. You can go through some proof to show it, but we know that this is an equilateral triangle, vertically opposite, and then you can use some other cycle theorems, maybe, to work out that this is equilateral. But this triangle is equilateral. So that means every angle is going to be 60 degrees. So just write that down. Each angle in an equilateral triangle is equal to 60 degrees. So 60, 60, 60. And so of this triangle, this angle here is going to be y plus 60. And of this triangle here, this angle is going to be y plus 60. So these two angles are also the same. Okay? And also, this angle of this big triangle is going to equal this angle of this big triangle, because they're both 60 degrees. Like we've said, each angle in an equilateral triangle is 60 degrees. Okay? So this angle is equal to this angle, and this angle is equal to that angle. So now we've got angle, 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 angle. So they are congruent via AAA. Question 18. There are only R red counters and G green counters in a bag. A counter is taken at random from the bag, and the probability that the counter is green is 3/7. The counter is put back in the bag. Then, 2 more red counters and 3 more green counters are put in the bag. A counter is taken at random from the bag. The probability that the counter is green is now 6/13. Find the number of red counters and the number of green counters that were originally in the bag. So, if we know that here, originally, so the old probabilities, we've got 3/7 is the probability of green. So that means the probability of red is going to be 4/7, because they're only red and green, so the rest must be red. So green to red must be 3/7 to 4/7, which just simplifies to 3 to 4, because you multiply both sides by 7. And now let's just say this is 3x to 4x, because we don't know how much they actually have. We just know that whatever this ratio is, multiply it by a certain number, x, and we'll get how many bags were originally in. So if x was equal to 2, then they'd have 6 green, and they'd have 8 red. But we don't know if it's equal to 2 or what it's equal to right now. We can figure that out in a second. So we have 3 lots of whatever number counters, and then we have 4 lots of whatever number counters for green to red. And now the new, we have the green counters, we're going to add 3 to them, and the red counters, we're going to add 2 to them. So new, we're going to have 3x plus 3, and for red, we're going to have 4x plus 2. The new is 3x plus 3 to 4x plus 2. Okay, and we're told that this equals, and we're told that the probability of green from here is 6/13. So if the probability of green here is 6/13, the probability of red is going to be 7/13. So this ratio is going to be 6 to 7. Okay, and this new probability, so 3x plus 3 to 4x plus 2, these are going to be the exact same, because they're both new probabilities, which we want. So they're going to be equal to each other. Okay, and like I said, the colon, you can just read that as over. So it's 3x plus 3 over 4x plus 2 is equal to 6/7. Like that. Multiplying both sides by the denominators to get that. Rearrange for x, so x equals 3. And we want how many counters were in the bag originally, red and green. Originally, which is the old, it was 3x and 4x. So now we know that x equals 3, so let's just put that in. Okay, to get this, so that gives us 9 to 12. So originally there were 9 green counters and 12 red. The diagram shows a hexagon, A, B, C, D, E, F. A, B, E, F and C, B, E, D are congruent parallelograms, where AB is equal to BC, which is equal to x. P is the point on AF, and Q is the point on CD, such that BP is equal to BQ, which is equal to 10 centimeters. Given that the angle ABC is equal to 30 degrees, prove that cosine PBQ is equal to that. So we've got AB, EF, so where is E? AB, EF, this parallelogram is congruent to this parallelogram, and we're told that AB is equal to BC, which is equal to X. So let's just draw on what we have. So X and X. I'm not going to draw on this 10 yet because I don't need that right now. And then we know that ABC is equal to 30. So we've got this triangle here. Okay, we could have this shape here, but that's just more confusing to work with. So we'll just use this triangle. So let's just draw a line across here at 30 degrees. And let's call this A. Okay, instantly there's something that should be coming to mind. We've got two lengths and we've got an angle in between. That's cosine rule. So we have A and B, we have B and C equaling X, cosine A, which is cosine 30 degrees, and A is just A. So just plug that into the equation to get this, and then simplify. Cosine of 30 you should know is √3/2, and then just simplify this. So these twos will cancel, so it's going to be minus x squared √3, and then that gives us what a squared is. I'm not going to work out what a is just yet. You can just square root all of that and then just leave it like that for a second. But the reason why I'm not going to do that is because we're going to need to use cosine rule again in this question. And cosine rule uses a squared. So there's no point of, we're going to be using a squared into there. So we're going to put this into there. So there's no point of square rooting this, just to square it again. It's just a waste of time. Okay. And you'll see what I mean in just a second. So let's just get rid of this information. We know that a squared equals, this squared is equal to this. And if you look at this, AC is equal to PQ. Okay. They're the exact same length. So let's just write that there. And we're saying that we want to find PBQ, which is what the question wants us to do. Let's just get this information down. So you have BP is equal to BQ, which is 10. And we can just get rid of this A here, because it's just going to make it a bit confusing. Okay. Cosine rule again, surprisingly. So we've got this angle here, and we've got the two lengths on both sides. We don't know what this angle is, but we can forget about it because we've got this length here. Okay. So if you've got three lengths, you can work out any angle in the triangle because it's just cosine rule. Okay. So this is going to be a squared equals this squared plus this squared minus 2bc cosine of this angle. So just put that into the equation like that. And like I said, this a squared, we're going to be using it again. So there was no point of square rooting this just to square it again. So we can just leave it like that as a squared, and then now we can put it in here to get that. And then here you can just factor out an x squared, and here you can factor out a 200 to get that. Divide this side by 200 to get that. And now we can add cosine theta and then minus whatever this is. Get cosine theta is equal to this. Okay, and this is very close. You probably get all the marks for this, but we're saying cosine PBQ. So we've just called this angle theta, but we can call it whatever we want. They've called it PBQ. So let's just write it how they want. So cosine PBQ is equal to that. And this is the exact same. So that's all 5 marks. Question 20. This is the last question. It's the highest mark question at 6 marks, I think. There are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. And there are more than 12 pens in the box altogether. Simon is going to take at random 2 pens from the box, and the probability that Simon will take 2 pens of the same colour is 27/55. Work out the number of green pens in the box. Okay, so let's just say, okay, we have green pens, so green will equal green, obviously, and blue pens. So we're saying that blue pens is always going to be 3 more than green. So blue equals 3 plus green. Okay? And this is useful because now everything's in terms of the same variable, so we can solve for that variable. So the probability of green is going to be green over probability of this over this add this. So it's green over green plus blue. That simplifies to this. So the green over the total, this is the total, so it's 2g plus 3. And that's probability of green the first time. Okay, so probability of green the second time is, now we have one less green, so we have green minus 1, and then the total is going to also be reduced by 1 because we've taken 1 out. Okay, and just simplify this to get that. So probability of green the second time is going to be this. Okay, so probability of green the first time, probability of green the second time is that. And we want the probability that he takes 2 pens of the same colour. So the only way that it can take 2 pens of the same colour is if he picks green and green again, or blue and blue again. So the probability of blue is going to be 3 plus g over the total, which is 2g plus 3. Let me calculate what the probability of getting green twice is. So we'll just multiply these two together. Okay, to get that, expand that, so it's g squared minus g. Then it's 4g squared plus 4g plus 6g, so it's plus 10g plus 6. Oh, I've not actually solved that, but that's what it is. Probability of blue is going to be g plus 3, or 3 plus g is the same, over the total, which is 2g plus 3. And then the probability of blue the second time is going to be 1 minus how many blues there are now, which is going to be g plus 2. And now because the entire total is being reduced by 1, we're going to reduce it by 1 down here. So it's g plus 2 over 2g plus 2. So the probability of getting green, getting blue twice is this multiplied by this. Okay, and let's just solve this. Okay, so this multiplied by this, this multiplied by that, so these two multiplied together is the probability of green twice, and this multiplied by that is the probability of blue twice. And we want to add these together to get the probability that he'll take any 2 pens of the same colour. And we know that that is equal to 27 over 55, which is what the question tells us. Now we're going to expand to get that, and then we're just going to put them over the same fraction. We're going to simplify the top. So g squared add g squared is 2g squared, 5g minus g is 4g, and then 6 at nothing is just 6. And then the denominator is obviously the same. Here you can spot that you can actually factor out a 2 and then cancel it. So cancel out the 2. So now we have g squared plus 2g plus 3 over 2g squared plus 5g plus 3. Multiply out by both sides to get that, and then expand, so it's 55g squared plus 110g plus 165, I think, and equals that, so just multiply this out, and then rearrange, so you get g squared minus 25g plus 84, and then this is going to be, what is it, 21 and 4? Yep, okay, so g minus 21 and then g minus 4. So that tells us that green is going to be 4, or green is going to be 21. But we can't have both of these answers, and we have to discard one of them. And to be able to discard one of them, we just need to look back at what the question tells us. So there are more than 12 pens in the box. So let's just test. Obviously, you might tell straight away here that g is just equal to 21. But the reason why g is not equal to 4 is because if we have 4 greens, then that means we're going to have 7 blues. 3 plus 4 is 7. So 4 plus 7 is going to be 11. But that's not more than 12. That's less than 12. So we can't use that solution. So the number of green pens, because it cannot be less than 12, has to be 21.